Imagine waking up tomorrow and the sun no longer looks the same. The morning isn't golden, it's blood red or electric blue or an alien shade of emerald green. This isn't a movie filter. This isn't Photoshop. It's the light that powers every heartbeat of life. Suddenly transformed. What would happen to plants, to our climate, to your skin, to entire civilizations? Would agriculture collapse, or would life reinvent itself under a new palette of energy? In this documentary, we'll uncover the physics of solar color, explore possible scenarios, from scientific plausibility to science fiction, and imagine how humanity might adapt, or even thrive under a different sun. If you love science mysteries, hit subscribe now. This video is packed with wonder, history, and mind-bending possibilities. What color is the sun really? First, let's debunk a myth. The sun is not truly yellow. It radiates across the entire visible spectrum and beyond, behaving like a near-perfect black body with a surface temperature around 5,800 K. According to Wien's law, its emission peaks near 500 nanometers in the green range. But because it emits all colors blended together and because our atmosphere scatters shorter wavelengths, blue light, we perceive it as white-yellow. At sunrise and sunset, the effect of Rayleigh scattering makes the sun appear orange or red since more blue light is scattered out before reaching us. So the sun is technically closest to white with a greenish bias. But atmospheric filtering paints it in shades our brains interpret as yellow. If the sun turned red, cooling worlds, a red sun could mean its surface cooled to around 4,000 K, shifting the peak emission to 724 nm, deep red infrared. Energy output per unit area would fall dramatically. Only about 23% of today's level, because energy scales with T4, impacts climate. Earth plunges into global cooling. Ice sheets expand, temperate regions freeze. Ecosystems' photosynthesis relies on 400-700 nm light. Red heavy light means chlorophyll works less efficiently. Crops collapse. Humans' mass famine energy demands for heating skyrocket. Vitamin D deficiency due to lack of UV. Historically, we've seen red suns caused not by stellar change, but by Earth's atmosphere. Volcanic eruptions like Krakatoa, 1883, filled the skies with aerosols, creating blood-red sunsets seen across the world. Those events cooled Earth measurably for years. So in the short term, if you saw a red sun, the culprit would likely be dust or aerosols, not the star itself. If the sun turned blue, a dangerous brightness would engulf the Earth, transforming familiar landscapes into scenes of chaos and despair. Imagine a world where extreme heat reigns, oceans evaporate, and mega-droughts stretch across continents. The atmosphere would be stripped of its protective ozone layer, leaving Earth exposed to relentless radiation, leading to skyrocketing cancer rates and increased blindness among the population. With plants and plankton collapsing under DNA damage, the very foundation of life would begin to crumble. In this new reality, life would be a constant battle against a mutation storm, where accelerated changes threaten species survival. Humans would have no choice but to rely on advanced technology and scientific innovation to adapt and create sustainable living conditions. Survival would hinge on the creation of these dome cities, where artificial habitats and full-spectrum shielding become essential. Inside, humanity would cultivate their world, striving for balance amidst the chaos that the blue sun has wrought. A green sun sounds fantastical. But remember, the sun already peaks in the green. Why don't we see it as green? Because all colors blend to white. For us to see a truly green sun, something must filter or reshape the spectrum, so only green dominates. Vision would be affected. Our eyes are most sensitive to green. The world may look flat, losing contrast. Aesthetics would change drastically. Human culture would reinvent art, fashion, and symbolism under an alien emerald glow. Biology would shift significantly. Plant photosynthesis might actually thrive if tuned precisely, or falter if the spectral balance is wrong. Most likely a green sun would be caused by Earth's atmosphere filtering out red and blue bands, an improbable but visually stunning shift. This transformation would prompt endless questions about our place in the universe, challenging our understanding of light and perception, while sparking new scientific inquiries into the nature of stars and their effects on life. In this altered existence, society would adapt, finding joy and creativity in new experiences, all under the watchful eye of a vibrant green sun that forever reshapes our world. While stellar changes take billions of years, Earth's atmosphere can change sunlight, color within hours, creating spectacular scenes like red and purple sunsets due to volcanic eruptions, or the haunting glow of wildfires casting orange smog across the sky. Dust storms and cosmic dust shift, how sunlight filters through the atmosphere, creating muted and golden hues, while pollution turns sunsets dim and gray, reminding us of our influence on the planet's color palette. Pollution and geoengineering may one day deliberately shift incoming sunlight, leading to potential futures where we see both thriving ecosystems basking in bright colors and stark environments struggling under dim engineered lights. History shows that such colorful sunsets have reshaped climate and culture, as ancient civilizations marveled at nature's displays, while modern farmers now contend with how these atmospheric changes affect agriculture and food production. These plausible color shift suns resonate with communities today as markets buzz with conversations about the effects of climate on crops, while classrooms ignite young minds to understand the delicate balance between nature and human influence. Light shapes our bodies and minds, illuminating the profound impact it has on human biology and psychology. Excessive ultraviolet exposure can lead to serious health issues like skin cancer and cataracts, while a lack of it can cause vitamin D deficiency and weaken immunity. Mood shifts occur as blue light suppresses melatonin, increasing alertness, while red light can evoke alarm or passion, and green light often feels uncanny. Circadian rhythm. Chaos emerges when exposed to new light spectrums, potentially rewiring human sleep patterns, productivity levels, and even mental health. Humanity doesn't give up easily. Our journey towards adaptation is filled with innovation and resilience, but the question remains, at what cost and who gets left behind? Controlled agriculture thrives with cutting-edge techniques, while bioengineered crops promise enhanced efficiency. Yet as we undertake geoengineering to shape our environment, we must ask ourselves about the implications and disparities of these choices. Migration becomes a reality for many, as families seek refuge in survivable zones. Within the safety of protected cities, life continues, but the shadow of who remains behind lingers in the air. The far future, when the sun will change. Billions of years from now, the sun will change color. When hydrogen runs out, it will swell into a red giant, larger, redder, but far more luminous. Earth will lose ocean's atmosphere and habitability. This cosmic future is unavoidable, but far beyond human timelines. For us, the real challenge lies in how we handle the atmosphere and climate we've already altered. The color of the sun isn't just about beauty. It's the foundation of life. Change the light and you change the rules of existence. If one day the sun turned red, blue, or green, it wouldn't just be a new sunrise. It would be the beginning of a new chapter for humanity, a challenge to adapt, to invent, and to survive. So I'll ask you, what color sun would you choose if you had the power? Drop it in the comments. And if this journey lit a spark in your imagination, like, share, and subscribe. The next great question may already be waiting in the sky.